Thank you for the opportunity. I would like to start with a very brief overview of what we have in PAWR, and this is the sort of cartoon picture we always use for that. We have a sizable outdoor deployment, we have rooftop nodes, we have a dense deployment, we have the massive MIMO systems provided through our collaboration with RISE. We have a CWDM front haul network to near edge compute facility. We have another near edge compute facility on campus, and then we have a much larger cloud facility in the University of Utah downtown data center. We have a controlled RF environment. We have an indoor over-the-air environment. We have a variety of endpoints that you can move within this context. So that's sort of, if you think of the physical infrastructure, quote unquote, city scale research infrastructure. As Manu said, really key things here, this is all remotely accessible. We heavily support bring your own device, bring your own software. And the key thing for our approach to this is we have a very sophisticated experimental control framework. We'll talk more about that in a second. And we kind of follow a software and hardware building block based approach where we provide bits and pieces, and you can bring your own bits and pieces, and we can flexibly put that together. So just sort of as a single line takeaway, would like you to think of PAWR as a highly flexible lab as a service infrastructure. So this is what it looks like on a map. We're mostly deployed on the University of Utah campus. The green area here is where we have our dense deployment. This is where we have our metro compute in the University of Utah downtown data center, near edge compute, a live map that shows the deployment and the buses going around. I'm really not going to spend time on this. This is all deployed. It's available. The only thing that is still in progress is the actual RF equipment for our dense deployment. But other than that, it's all available. We will send out a pointer to these slides momentarily if my colleagues haven't done so already. And there's details of the infrastructure and the hardware building blocks further down in the slide deck. So let me change gears and talk a little bit about Open RAN in PAWR. And we've done a couple of things Open RAN related. The first one was really we had wanted to make ORAN available as a building block. Again, software, hardware building blocks, sort of the way we think of the world. And the problem we saw at the time was that there were software building blocks available, but you really couldn't do an end-to-end or a top-to-bottom environment because a lot of these pieces were not open source. And so the first fairly big effort that we did was to try to provide such an open source top-to-bottom environment. And we, to make it realistic, we picked a specific use case. So resource management in a sliced RAN environment. So we did an E2 agent and RAN slicing functionality at the sort of the CU/DU level. We realized the RAN slicing service model, and then we also implemented an XApp to control that little environment. Of course, we have a SMO or service management orchestrator environments available as well, although we didn't use that for this use case. So a little bit more detail. We basically combine the ORAN Alliance open source RIC with SRS RAN at the bottom, and then these pieces as I described a minute ago. So lots of pointers to that particular work, again, that you can follow up later on. Another big effort that we took part in together with our friends at Cosmos was to support the most recent ORAN Alliance Plugfest. And our involvement there, just going back to this cartoon picture, was mostly using the compute capabilities. So the software, specifically building blocks, and bring your own software capabilities. And this is an attempt to kind of show how that played out. Right, so the pink here, think of this as the platform, and then we have this profile abstraction in our environment. And you can think of a profile as a recipe that really could just give you bare metal access to compute, or it could provide you with all of these different stacks sort of ready-made. And so this really worked out quite powerfully in our support of the ORAN Plugfest, in that these users came in and they picked different base profiles, as it were, and then added their software on top of that. So a little bit, just to belabor that point a little bit, the profile process, you have a profile, so like in this case, might be a Kubernetes profile. You specify the resources you want, it gets instantiated in the platform automatically for you, and then users come in and can instantiate their software on top of that. So this is kind of our way of thinking of the world: on demand, sophisticated stacks that you can get and get your own private copy of that. This allows us to make efficient use of resources, of course, and kind of fits where industry trends are. But we can do dedicated deployments if that's of interest, and it seems like specifically for industry folks, sometimes that is the case. Just quickly, what we did end up supporting, the main thing we ended up supporting with, and this was the driven by the AT&T side of the proof of concept, Plugfest and proof of concept, was this multi-operator, multi-vendor environment, and we were interconnected with Cosmos for that. And then we supported a number of other software environments. So there was near real-time rig testing, 2 versions of that, and also cloud testing. And so big takeaway for us from supporting this was the feedback that we got from these participants was that it'd be really nice to be able to do testing at any time continuously, and not just during the 4 weeks of the Plugfest. And so sort of our key insight was that, we have the pieces with our building block-based approach to make that a reality. And so we've been thinking for a while now of on-demand ORAN testing capabilities. So back to this kind of picture, same thing. We have these profiles that we make available, but then extending that with specific functionality to enable a testing workflow. And this workflow might include directed graph of actions and other workflows. And the point again is to try to automate that. So here is what it looks like in a little bit more detail. And of course, the automation itself is for us just another profile. So there's a powder testing automation profile, and that might contain elements like this. So these are specific with our current prototype implementation. These are the specific ones we picked, but this of course generalizes to other approaches as well. So the thing driving all of this is the workflow engine, and we picked StackStorm. We added abstractions so that could interact programmatically with the PAWR APIs, instantiate profiles, make selections in terms of resources. We use Ansible for configuration management, and then the robot framework to do the actual tests. And then you gather all the results up in a test case management system. So this is the idea. Of course, you can easily see how this could be extended and adapted. For example, if you want to do CI/CD workflows, then maybe 2 and 3 here would map into those existing CI/CD workflows. Here's a quick example of that. This is one that we've been working on. So imagine you have a rig that you want to test, and you have some rig testing software. So the workflow engine might deploy the rig testing software, deploy the rig, run the test, collect the data. We actually have initial prototype that performs a part of this. It deploys the rig, do some basic smokestack testing with that, and there's some videos that describe that in more detail. Of course, this approach generalized beyond just software, right? You could, let's say you want to do an RU test, or ORU, I guess, as I say in ORAN. So there might be a, step 0 might be a manual step where you actually plug this in, connect it to a signal generator analyzer. But then the rest, again, could be automated, where you instantiate the testing software and you run your test and collect it. We have ambitions to become an OTIC, so we've been interacting with AT&T on that, with other partners. We're in the process of also exploring testing partners. And what we expect is to have this ORAN lab as a service, and specifically focusing on the on-demand automation and semi-automated testing for that. So that was the ORAN slides. Open source, our strategy with open source, we kind of think of that as domain-specific software, and so we try to get instances of that is relevant to our users, stabilize it, make it available on PAWR, and make it really make it work through all our different subsets of environments, and then also deploy it scalably on PAWR. We have all the 4G stacks, of course, 5G stacks. We have other like ORAN, ONAP, Kubernetes, OpenStack. And then, of course, we have the massive MIMO stacks that we're getting from our Renew partners. This is a specific example just to belabor the utility of the platform. And this one is actually a use case. We recently supported the OAI workshop. And the thing that we emphasized in that workshop is that on this platform, you can go from simulation to control RF to indoor over the air, and then eventually to outdoor over the air. Right? And again, that makes for a really nice development environment, because you can kind of figure out what it is that you're doing, and then start to use actual RF resources as that becomes necessary. So there's pointers here about the details, which I'm just going to skip in the interest of time. Here's some details about our 5G specific efforts so far. So mostly OAI, both the non-standalone and standalone. We've also worked with the Open 5GS and UE Ransom. Again, there's profiles and videos available for that. We have these other stacks as well, like I mentioned already. I mean, we have a SMO, if you ORAN speak, or the ONAP environment. We have basic container profiles, Kubernetes, Cloud Stack, etc. I think the Renew folks will maybe talk a little bit more about this, but with our partnership with them, they provide us with open source software for the massive MIMO equipment. There's a basic lab available and the baseband real time, and they're working on a MAC layer stack as well. So this is my last slide. So I think the high level takeaways here is just, you want to think of, we have a pretty sophisticated lab as a service environment. Of course, by now we have developed fairly extensive domain expertise in supporting these things, and we're interested in partnering and collaborating with industry along the lines of what's on the slide here, and indeed any others that you might be interested in.
There's another PAWR platform. First slide, mandatory slide, a lot of people involved. So I'm just flashing this so that, and of course, slides will be made available. A lot of people involved. Main players are Rutgers, Columbia, NYU, New York City, Silicon Harlem, City College of New York, University of Arizona, and IBM. And so same as with PAWR, just a very brief introduction about the Cosmos project. So the whole vision is to sort of focus on two important components, which are the latency and compute power needed to support advanced wireless systems. The edge computing is seen as one of the most important parts or enablers for the real-time applications. And therefore, the focus is really on supporting new real-time application on top of advanced wireless systems, right? So standard sort of 5G or beyond 5G focus on ultra-high bandwidth, low latency, and densities, given that this is deployed in highly dense urban environment. And so the enablers are really the millimeter wave and a lot of optical support for it, and of course the edge computing and programmability of the whole system. So I'm just browsing through these really slides that are showing sort of deployment that we already have. The core of it is focused on what we call the 9 large sites, right? So those things, you can think of these as sort of rooftop deployments. 40 medium sites, which are street level or mounted on the lampposts, and then of course a number of small nodes, which we jokingly call near portable, because obviously these are fully programmable devices and therefore are not something that you can easily put in your pocket, but most probably either carry with both hands or more likely deploy in the vehicles or buses. The coverage area is really the West Harlem, spanning from 120th to 135th Street and between Amsterdam Avenue and Broadway. So it's about 1 square mile of 15 city blocks. Key technologies, software-defined radios, millimeter wave, optical networking, and SDN and distributed cloud. The core of the millimeter wave deployment is the IBM array, fairly sophisticated and interesting array. With 64 elements, it's a hybrid array. The reason why it's so interesting is because it can be either used as a very sharp single beam array or alternatively as 8 simultaneous arrays or 8 simultaneous beams, making it quite interesting for a base station side of things, right? And then the focus and part of my talk will be actually focusing on optical networking, which is viewed as sort of a very necessary part of the future wireless deployment because it provides the backhauling or X-hauling capabilities. Now, the deployment is actually done in phases, and similarly to how PAWR is sort of focused on expanding their coverage, we are we finished the pilot phase in May of 2019. Interesting event that happened is the declaration of FCC Innovation Zone that happened in September of that same year. And in June 2020, the testbed was made generally available. Unfortunately, the phase 1, as one can expect, due to COVID, was sort of slowing us down and prevented us from expanding as much as we wanted. And we are still in process of actually pushing the connectivity further up the Amsterdam Avenue. Fiber, actually our fiber plant is pretty much fully deployed at this point. We have connectivity between Columbia and City College, Columbia at 32 Avenue of the America, and the rest of the testbed, which is in New Jersey. And on top of that, we have connections to international partners through the COSMIC project. I mentioned experimental licenses, and that's something that industry is obviously quite interested in. You can actually see here the list, and pretty much all 4, I believe all 4, or actually all 5 PAWR platforms now have some form of FCC Innovation Zone declaration. And then in addition to that, all 3 institutions have what's called the program experimental license, which allows us potentially to play with some other frequencies that are not listed in the innovation zone. Now, I was going to talk mostly about industrial experiments that were done on the testbed so far, much less about the research topics. So the first one that I really want to emphasize is that was done by Nokia Bell Labs, and that is actually a campaign that's still going on 28 gigahertz sort of measurement campaign. And it was done in sort of 2 phases. One was literally what we call the outdoor phase, which is to sort of look at the outdoor to outdoor propagation characterization, and in collaboration with the WiMet lab at Columbia, they performed about 41 million measurements along the 22 sidewalks at 4 different sites, both line of sight and non-line of sight. At a little bit later, that was followed by the 45 million measurements on outdoor to indoor measurements, where they looked at propagation of through the buildings and the walls and windows of the various schools in the area. And as you can see there, we have about more than 5,000 links fully characterized with these measurements. And you can actually see the papers, and once the slides are available, you'll be able to sort of look at the details. We think that eventually some of these will actually be made available to the community as a sort of reference data sets. I said optical is one of the critical components that industry is seeing as sort of necessary to support advanced wireless communications. So one of the features of the Cosmos testbed is what we call composable X-hole networks. And you can actually see here the sort of types of configurations one can do. It's mostly based on this star topology where all our fibers are ending up in the massive space switch, the Kelient 320 port switch, sitting in the core of the deployment, which then allows us to create all sorts of different and interesting configurations. So this capability was actually used by quite a number of companies, and actually this fairly interesting experiment done on optical telemetry and control testing, where they collected a fairly large number of measurements in support of AI-based control that have sort of potential to overcome the challenges of these disaggregated optical systems. And so one of the things that sort of is interesting is that optical deployment is pretty much the only one where if one creates a wrong configuration, potentially can start frying equipment. So that's where we sort of try to sort of claim that in order to use these facilities, one has to prove that they know what they're doing with the fiber footprint. But nevertheless, this was an example of industrial use of the Cosmos testbed for advanced optical measurements and deployment. Quite a lot of interest comes up from the fact that Cosmos, in addition to wireless and computing and optical capabilities, also has each of the sites, especially the medium ones, have the built-in cameras, and therefore can be viewed as sort of the core of the smart city application platform, deployment platform. And so especially our pilot intersection of Amsterdam Avenue and 120th Street actually has 4 cameras monitoring the intersection. Of course, the idea is to sort of combine radios, cameras, and edge cloud and computing nodes with, by the way, all the facilities of all computing facilities in Cosmos have both GPUs and FPGAs to sort of deploy all various AI/ML algorithms that are sort of envisioned as integral part of the smart city applications. And as an example, the idea is to sort of detect and track all the objects in the intersection and to sort of create a closed loop with actuation and the latency of about 10 milliseconds. And as one can imagine, and I'll try to play the video, so I hope it's going to work. The idea is to sort of create something like this, where by using multiple cameras, one can create what we call the radar map and sort of distribute that to all the participants in the traffic or for city planners. The tricky part and something that's not actually mentioned here is that this is significantly below real time, at least at the present state of technology. And that's actually something that apparently a lot of people are interested in playing with, right? And trying to reach that goal of real time closed loop, sub 10 millisecond type of thing. Now, going further, next thing that we sort of very recently introduced, and I believe this is the first time we are showing this capability, is sort of in collaboration with the Siemens. We have an industrial lab extension, what we call the Weeks Hall, which in addition to Cosmos equipment also has robotic manufacturing setup. And you can actually see it here. The idea is, of course, to sort of look at these industrial automation and smart manufacturing type of application, applications which require combination of low latency and high computing requirements. Similarly to actually these two capabilities, the smart city and industrial lab extension, unfortunately are not something that's easily made available to external experimenters and probably requires on-site presence. Clearly for industrial lab, it's a little bit dangerous to let somebody far away control this robotic device, especially when there is a piece of equipment that's rotating at 22,000 RPM. Similarly, the outdoor smart city type of thing is really not the issue of remote access, but rather the issue of IRB. And that's something that, of course, we have to take case by case and requires prior application in order for external users to use it. But we can work on that, and we did quite successfully with a couple of partners already. Now moving to the topic of ORAN and ONAP, right? So as Kobus mentioned, both of PAWR and Cosmos are trying to become what's called the OTICs, right? Or we are candidate OTICs. OTIC stands for ORAN Test and Integration Center. So Cosmos has been used since 2017, actually, even prior to actual establishment of Cosmos, as the ONAP lab, right? And we have a permanent ONAP setup that's been funded by the industry that consists of 16, actually now it's more than 20 servers that are managed by OpenStack, and that community is at large is using on a permanent basis. And actually that's something that, as Kobus mentioned, they really want to have this capability available at all times. And this deployment is actually dedicated to ONAP and ORAN communities, right? Now, I will breeze through these slides in interest of time, and you heard quite a lot about the PAWR from Kobus. I just want to point out that the last Plugfest, which happened in December, actually late November and early December, was sponsored by Verizon and AT&T, and it had 3 sites. The Telecom Infra Project Deep Community Lab in Facebook or Meta in Menlo Park was one of the Plugfest labs, and then University of Utah and Rutgers were PAWR labs, and meaning the PAWR sites. And Rutgers was also a Plugfest lab for the testing. Now, just to sort of look at the expansion and what's going on, you can actually see the progression. So the number of people participating is growing significantly every year. Next Plugfest, as far as I know, is supposed to be 3rd week of June this year. And based on the announcements, we will have even more people participating. And of course, hopefully in the meantime, we'll even become an official OTIC centers, and which would make things a little bit easier in terms of organizing everything. This is the list of companies that participated in the last Plugfest. Unfortunately, there are all sorts of restrictions of what we can say about the Plugfest itself. You heard enough about the proof of concept. I'll skip that, but just want to say that sort of Plugfest is quite intensive in the sense that people come on site, bring all their equipment, plug it in, and sort of look at all sorts of combinations of tests. Quite exhaustively. It takes about a week for a particular Plugfest to happen. Actually, it's a little bit less, but with all the setup and breakdown, it's quite intense. PAWRs, I'm not going to spend any time on because...
apologies. We have about 9 or 10 minutes left. If you don't mind, just wanted to switch
this is it.
questions.
I just want to sort of say, the educational toolkit is one thing that actually quite a lot of industry support we get from. And this is the last slide. So more information is available on these links.
Thanks a lot. Thanks, Ivan. So please, the floor is open. If you have any questions, just to seed some thoughts for the rest, and maybe Kobus, you can react first, and Ivan would love to hear your thoughts. One thing I think, at least in the ORAN ecosystem, that's being looked not just by industry, but also by federal labs and the government, is around Open RAN security. So any kind of notional ideas of what kind of work, if not your own individual institutional research, but other activities that you're seeing in terms of how your platforms can help support the security risk analysis, threat models, physical layer security, MACsec, interface, some work that's coming out of the SFG within the ORAN Alliance. And then also any ideas on, given that a lot of the federal ecosystem, and especially this is a very US-centric question, don't necessarily have membership or visibility into the ORAN Alliance, how do you think your sort of platform resources and your, the sweat equity you've built over the past year and a half can help inform, questions, considerations that policymakers and the federal ecosystem should be looking at? I know it's a loaded question, but whichever of these you want to react to.
It's also a very long, multifaceted question, so
yes.
I'll try to remember. Well, in terms of the security, I do think there's various open issues around ORAN that I think people are rightly concerned about. And, as you kind of alluded to in your question, there's, in some sense, there's the radio aspect of it. And now you're saying, oh, by the way, we're opening it up to some extent. And the way we're opening it up is we're adding all the software, and as we know, software has bugs, right? So it's just, there's I think a whole number of possible attack vectors on the negative side. Maybe on the positive side, of course, the fact that you are opening things up might actually enable new ways to deal with security, right? So, for example, you might, and I think this is still to be determined whether this kind of visibility would be feasible through an ORAN abstraction. But if you have enough of a visibility of what's going on at the lower levels of the radio stack, this is a place where you can apply machine learning and say, do I see anything that's going wrong here that looks anomalous? So I think that's a very interesting space. Maybe transitioning to how I think we can support it. I think this is in part why we have this interest in having building blocks that people can instantiate themselves, right? So if you're interested in doing some sort of an attack on a system, it is probably better if it's your own system that you're attacking and not some sort of a shared system. So that's, I think, our model of on-demand, get your own instance works well with that. We also have with our different environments, I think the ability to try things out. So, we have a controlled RF environment. So more flexibility in terms of the spectrum that you might want to use, more flexibility in terms of actually launching attacks, right? There's been a number of really interesting physical layer attacks that came out in the last couple of years. And, so these are the kinds of things that you'd probably want to do in a controlled RF environment. And then working from there, I want to say sort of up the stack in terms of dealing with the security aspects. I feel like I didn't get to the last part of your question. Remind me, what was that, Mani?
That was more just to inform, right? Given that you could act as a proxy in
right.
The federal lab ecosystem and partnerships in there. Any?
Yeah, thank you. So, and again, this is, so there's, of course, the ORAN Alliance with their OSC, their ORAN software community release that is open source. And that's where we started off with our work. And so we make that available because that is available now generally, right? You don't have to be a member of the ORAN Alliance to get that. We've also more recently been working with ONF. That's, I guess, there are many stacks nowadays, but I would say, at least in the US, ONF is probably a key other player in this ecosystem. And again, the way they do it is they have stuff that's members only, and then there's stuff that's publicly available. And so we have a profile now for the publicly available part. And so, I think in that sense, we enable players who might want to just kick the tires, or maybe grad students from universities where they're not part of these organizations, to have the building blocks to start playing with it.
Ivan, thoughts on security experimentation?
Well, so I think that's actually something that the industry is also interested in. So the way I see it is sort of if anybody can come up with the blocks that can be added on, Plugfest would be a place to sort of test them out, right? In other words, if you can sort of come up with the block that somehow improves security of the overall system, that sits, say, in between two components or sits somewhere on the fringes of the deployment, that would be a way to sort of test it. And the question on what can be done essentially is sort of fairly straightforward, right? I mean, these Plugfests are not yet at the level where they test end-to-end systems, right? So they are usually a much sort of component or part of the system being tested. And therefore, it's not easy to see how, at the moment, security testing could be deployed overall. And even the attacks are not clear, right? On the other hand, I'm sure there are people who have ideas on how to do it, and maybe they should be invited to these Plugfests or offer their components to do it. Now, as far as dissemination is concerned, there is actually an issue with as Kobus alluded, right? There are things we should not be exposing to people who are not members of the alliance. So I don't know how to deal with that. That's one of the things. But maybe we could come up with some sort of a preliminary report that is vetted by the alliance and given to everybody.
That's great. And I think Tom from CTIA has a comment where, again, the ORAN security question is being looked at the CISRIC in the FCC. So this will be very interesting. And I think it'll be great if the platform can actually help enable either experimentation or submission or just share information, given the neutrality that the test.
I think both platforms are quite capable of exposing all sorts of things, right? During, before, or after. The only question is if everybody agrees that that's meaningful. And of course, the stuff that's fully open source, there are no problems with
exactly
sort of playing with.
That's a great point. There's a question in the chat from Akbar. I'm unfortunately I'm going to parse it the best I can, but there's a question around achieving low latency and any quantifiable data. I'm just going to tie a wrapper around if you can just give maybe 30-second summaries on data management and data access from your platforms. And Akbar, maybe I'll let Kobus and Ivan answer that question in the chat for you. But if you could just talk a little bit about the data aspect, because that's also going to be very crucial for ORAN, especially as you talk about RIC and optimization and closed loop systems, et cetera. So, and that'll be the last one. So Kobus, you, and then Ivan.
Sure. Yeah, I mean, we have a big push on data collection, and there's actually in the slides that we shared that I didn't cover, some of pointers there, specifically more on the spectrum side of things, and not so much on the ORAN side. So that's definitely a big push for us to make good data sets available that we collect ourselves. Of course, this is a platform where our users can also collect their own data, and we'd be happy to support them. And we have tools and mechanisms to allow them to do that if they are inclined to do it themselves.